Hello everyone, welcome to my YouTube channel called Zen. Today I am going to start a new playlist in my YouTube channel. It is about data structures and algorithms. This is the first video of this playlist, and I wish to discuss the introduction to data structures and algorithms in this video. Also, I will discuss what is data structure and algorithm, why it is useful, and the real world example for data structures and algorithm. Okay, mainly we will see what is a data structure. Before that, I should tell you data structure and algorithm is not a same way, same things, because they are different two things. Separately they have two different behaviors. Okay, we will discuss furthermore. In the first we will discuss the data structure. What is data structure? Data structure is a way of storing and organizing data so that it can be used efficiently. That means data structure is a way of storing and organizing data. For example, think of bookshelf. If books are arranged properly, you can find a book quickly. But if they are scattered everywhere, searching takes a lot of time. That's the example for data structure, a bookshelf. Also, why are data structure important? Why data structures are important? Data structures help in faster processing. That means your programs run efficiently, and also simplifying complex problems, breaking big problems into small ones. Essentials for programming. Also, data structure helps in essential for programming used in all applications. And also, data structure helps in competitive coding. That means helps in solving hard coding challenges. Also, we can get for examples for the data structure: arrays, linked list, trees, and also stack, queue, stack, and graph. Okay, we will see the types of data structures. There are mainly two types of data structures. They are linear data structures and non-linear data structures. What's the meaning of linear data structures and non-linear data structures? Linear data structures means data stored in a sequence. And also non-linear data structures means data stored in a network-like structure. There are some examples for the linear data structures and non-linear data structures. They are the linear data structures, and these are the non-linear data structures. For linear data structures, there are example: array, linked list, stack, and queue. Array, linked list, stack, and queue. We will discuss about those things shortly. That means array means where it like a train. Array is like a train where each box has an item. Did you understand? That means array like a train. There are so many boxes in a train, and where each box has an item. So array like a train. And also in the next one, linked list like a chain. Linked list like a chain, where each link connect to the next one. And the next one is stack. stack is following the last in first out, that means LIFO behavior. That means it's like a stack of plates. That means we will get a stack of plates, plate stack. We normally use the topmost plate at the beginning. Okay, we normally use the topmost plate at the beginning, but the topmost place has been stored at the last. Did you understand? That means the last in, last stored, and first out, first removing. Do you understand? That's a LIFO behavior. And also Q is a non-linear data structure. Q means it follows the first in first out behavior. It like a queue in a bank. That means the first man in the queue, the first thing use the first store. Okay, then we will see the next type of data structure, that the nonlinear data structure. For nonlinear data structure, tree and graph is an example. That means tree is like a family tree. That means there are parents and also child. That's a tree. Also graph is used for social networks like Facebook. Okay, that is a real world example. Okay, then we will see what is an algorithm. I said in previously that structures and algorithms are not same. So we will see what's the difference of that. An algorithm is a step-by-step method. An algorithm is a step-by-step method to solve a problem. That means, is there any problem, we can solve the problem in step-by-step. That is the algorithm. So, for example, making tea. Think the making tea is the problem for us. So, the algorithm for solving the problem making tea is boil water, secondly add tea leaves, and thirdly pour into a cup, add sugar and milk, and serve. That is the step-by-step method to solve the making tea problem. So we can say that is the algorithm which to solve the problem making tea. So this is the difference between structure and algorithm. Structure is I said in previously, structure is storing and organizing data. Data structure means is a way of storing and organizing data, but the algorithm means it is a step-by-step method to solve a problem. Okay, then we will see what makes a good algorithm. What makes a good algorithm? That means characteristics of algorithms. A good algorithm should be correct and efficient and finite and also clear and optimal. What are these? Correct means gives the right result. Also, an algorithm should always give the right result for the customer problem. Okay, and also what is efficient? Efficient means uses less time and money. It is so efficient for the customer. Okay, the for a good algorithm, it should be efficient, and also it should be finite, should end at some point. That means it shouldn't be infinite. Okay, there always, if this is an algorithm, it should always has a end point. Okay, also for a good algorithm should be clear, easy to understand, it should be easy to understand, and also it should be optimal, that means best possible solution. Okay, then we can discuss the example finding the maximum number. Okay, that means we can find in the maximum number. Given a list of numbers, find the largest number. Okay, this is the normally we get example for data structures and algorithm finding the maximum number. The problem is, given a list of number, find the largest number. Okay, we will see the steps for that problem. Start with the first number as max. Start with the first number as max, and we can compare it with other numbers. And if a bigger number is found, bigger number is found than the first number, we can update max as it, and also we can repeat it until the end. After the end, we can return the largest number. This is the example for data structure and algorithm. That means we can store and organize the numbers, given numbers. That is the data structure, and we can find the max number, that is the problem, and this is find the max number from these steps. These steps are algorithms. This is the example for data structure and algorithm. Okay, then we will see real world applications for DSA. DSA means data structure and algorithm. For example, we can get Google search. This is very famous example for real world. That means Google search uses trees and graphs to find results. I told before, trees and graphs example for data structure. So for DSA, real world application is a Google search, and also Facebook and Instagram. It uses graphs to connect users. It uses graph to connect users. That means there are so many friends for a person has so many friends. That means it uses graphs to connect users. Okay, then also Amazon and eBay. It also a real world example for data structure, and it uses queues and hash tables. It uses queues and hash tables for product recommendation. That means if we are logging to the Amazon or eBay website, they recommend some products for us. That behavior use the queues and hash tables. Okay, I think that is it. I think you learned the basic of data structures and algorithms. If you found this helpful, like and subscribe for more content. Okay, thank you, bye. Okay, and that is it. I think you learned the basics of data structures and algorithms in this video. If you found this helpful, like, share and subscribe for more content. Thank you, bye.